G'day guys, Will here. Welcome back to the channel. So today's video, we're going to be taking a look at the TrueDrive software from Simucube, which is the software that you use to control your Simucube 2 wheelbase. So we're going to be taking a deep look at the software, all the different fine-tuning adjustments that are available there, what they all do, and how you can fine-tune the driving feel to really suit your particular preference. But before we do that, I want to talk a little bit more about exactly how force feedback works, because I think it's really important to have a fundamental understanding of a little bit of detail here before we really get involved more in the Simucube software itself. So I will provide timestamps in the description below if you do want to skip through to any particular parts, but I really would encourage you to at least watch through this first part where we're going to be talking about force feedback in a little bit more detail, because I feel like the information that I'm going to share here is fundamental to understanding things later on in the video as well. So we're also going to talk a little bit about the whole ecosystem debate at the moment, and the whole Fanatec versus Simucube thing. I'm not going to go into a whole lot of detail there, but I do just want to draw attention to a couple of things there, a couple of different approaches in the two different ecosystems as well. So this video is going to be beneficial to you whether you're trying to decide whether you want to buy a Fanatec wheelbase or a Simucube wheelbase, you're trying to get the most out of a Simucube wheelbase that you've already purchased, or you're just interested to see exactly how all of this stuff works. So we're going to start off by talking about exactly how force feedback works and how the motions that are replicated in a simulator are actually transmitted through the software into the wheelbase and into your hands. So the way this all happens is through an API from Microsoft, or application programming interface, called direct input. And I'm going to bring up on the screen for you now a very basic description of exactly how direct input works. So force feedback effects are generated by motors mounted in the base of a joystick or a wheelbase, obviously. Through Microsoft's direct input interface, devices are capable of generating those kinds of push or resistance in an input device. That's a little bit of pidgin English there. I'm not sure exactly what that's trying to say. So every particular effect, for example, the engine of a wheel car, needs to be created separately for every single device. Now, this is where things get really complicated, because this is where we get into the whole canned effects thing versus physics generated effects. So take a title like Race Room, for example, that uses a lot of canned effects. So say, for example, if you're running over a ripple strip or you go over a bump in the road, what it's effectively saying is, here is almost like a sound file. It's saying this is the effect of a ripple strip, and you're going to play this effect for this duration while you're on the ripple strip and at this amplitude or this volume. So obviously the more I guess aggressive the ripple strip is, the more aggressive or the more amplitude that effect will have, but it's going to feel the same every single time, just with the parameters of duration and amplitude. So the way those effects are created are using 4 different types of force. So we've got constant force, which is a constant force in a single direction. So that'd be like, for example, you're turning into a corner and you feel the weight of the wheel against you. That's a constant force fighting against you. And then we have ramp forces, which are forces that increase or decrease in magnitude. And this could be things like, the resistance of the car fighting against you as you turn into a corner. And you can feel that varies in its amount as you're cornering, depending on your speed and things like that. We have periodic effects as well, which are forces that pulsate according to a wave pattern. So this would be a good example of something like a ripple strip, where it's just like bang, 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 bang. So you can imagine like a sine wave it's almost like just a sound file that's playing through the wheelbase there. And then we also have conditional forces as well, which are forces that counteract the forces that you're putting into a wheel. So a good example of that would be the spring effect that you feel fighting back against you as you turn the wheel. So those are effectively the 4 different types of effects that we have to generate every single thing that you feel through the wheelbase. And they're all generated by the Microsoft Direct Input API. So the thing that's really important to understand, well, there's 2 things that you need to understand here. The difference between canned effects, which are effects that are generated by the sim and basically just played back whenever a scenario calls for them. And then we have physics generated effects, which are like what happens in iRacing, where the physics engine itself is actually generating the effects using, again, these 4 different types of parameters, but actually generating them through the physics engine in real time. Now, there are advantages and disadvantages of both. Obviously, canned effects tend to feel a little bit more canned, obviously. They tend to feel a little bit more repetitive, and because they're not able to adapt other than their duration and their amplitude to, the environment or the physics that are going on around you, they tend to have a little bit less of an immersive overall interpretation to the driver than a physics-based effect would have. But the trade-off of a physics-based effect, and iRacing again is a good example of this, is that you're limited in the amount of processing power that you have available to you. So for in the case of iRacing, for example, that the direct input API is actually only updated at a rate of 60 hertz there. So you can imagine if your monitor is refreshing at 120 hertz, so there's pictures changing 120 times per second, but your force feedback is only changing 60 times a second, what you're seeing on the screen isn't being represented by what's happening on the wheel in, it is in real time, but there's details that are being skipped. So for every 2 updates of the screen, you're only getting 1 update of the wheel. And you can imagine if you were to lower that sample rate even further, you start to feel that kind of notchy effect. And that's what gives you that kind of robotic movement that you feel in the cheaper wheelbases. So you can imagine if we're only getting 60 samples per second, we only have 60 opportunities for the wheel to update its position and the effects and things that you're feeling. So you can imagine if you're turning, it's going, okay, go here. Okay, now go here. Okay, now do this. Now do this. Now do this. Now do this. And it's changing, and it's doing it 60 times a second in the case of iRacing. But you can imagine that in the pockets between when that update is happening, there's no data being transmitted, so therefore there's nothing for the wheelbase to really know what to do with. And that is where the filters and effects that you have in the driver software come into effect. So that's what I really want you guys to understand at this point here, is that when you're dealing with direct input signals, you are limited by the sample rate or the data rate of the sim itself. And that varies between the different titles. I'm not going to go into that in this video because I don't think it's really necessary to go into that level of detail. But when you've got a signal processor in a wheelbase that's able to update, at something like a sample rate of something like 24,000 hertz, and then you're kind of using that based off a signal that's only updating 60 times a second or 60 hertz, there's a lot of stuff that's going on in between that needs to sort of be accounted for. Now, this is called interpolation. Now, interpolation basically creates data for the points in between the real data. And a good example of this is in picture engines on TVs. So if you've ever seen TVs that are advertised as being like 1,000 hertz and things like that, obviously the refresh rate or the signal that's actually coming into the TV is a lot slower than that. So what the TV does is it actually draws frames in between the actual frames. So it's getting, say a frame rate of 24 frames per second, but you don't want to see a jerky picture. So what it does is it actually goes, all right, well, I have frame A, and I have an idea of what frame B is going to be based on what I saw in the previous frames. So therefore, I can sort of interpolate, or I can simulate, or I can guess what that middle frame is going to be. And therefore, I can create an image that is going to be somewhat close to what the next frame is going to be. And effectively insert frames in between the actual frames to create a more fluid kind of look to the overall picture. And that's exactly what's going on with our wheelbases as well. What it's doing is it's saying, okay, I know the previous bit of data from the direct drive input was this. The one that I'm dealing with now is this. So there's a good chance that the next one is going to be this. And therefore it can kind of smooth off those inputs in between. And it's doing it at a absolutely incredible rate. It particularly, if you look at the data rate that you're dealing with the processor that's on the Simucube 2 Ultimate, it's almost completely saturating the USB bandwidth of your PC just in the, the data that's being sent out of the driver. And then we've also got signal processing that's happening on board the wheelbase on top of that as well. So it's an absolutely crazy amount of data that's going on. And that is a big part of the difference between what makes a really expensive and well-designed wheelbase on top, over what you get with something, like a cheap entry-level cog-driven or belt-driven wheelbase. So it's not just the quality of the construction and, the quality of the motor, the power of the motor and things like that. People often get caught up with, well, this wheelbase is, 30 Newton meters and this one's only 15, so therefore the 30 Newton meter one is better. That is true for the motor itself to an extent, but there is a lot more that goes on in the background that's important to creating an overall good feel. And, if you've ever looked at a robot and looked at robotics technology over the last 20 to 30 years, if you watch a robot moving around or walking or something like that 20 years ago, it was very jerky and it was very, I guess, robotic in its movement. Whereas these days, robots almost move like humans do. They're very, very, very fluid. And the reason for that is that we're able to update, or we're able to have a much higher sample rate these days, which means the motors are able to respond far more quickly to fine little adjustments, and we're able to feed them a lot more information more quickly to really create that fluid and human-like movement. And that's exactly what we're trying to establish here, or trying to achieve here with our wheelbase as well. We want things to feel as smooth and as, you know, as natural as is humanly possible. And, you know, with the technology the way it is these days, we're getting ridiculously close to, you know, the feeling of a real car. In fact, I'd say, honestly, with the Simucube 2 Ultimate here, I genuinely do forget that I'm not driving a sim sometimes. The feeling, you know, the inertia and all those kinds of effects that we'll have a look at in just a moment, you know, they really do feel exactly the same as they do in a real car, which when you think about what's going on in the background, and the fact that it's able to do all that signal processing in real time with zero latency effectively. I mean, I'm not perceiving any latency at all with the effects that I'm feeling through this wheel versus what I'm seeing on the screen, which, you know, when you think about it, that is pretty darn incredible. So anyway, I just wanted you guys to understand a little bit more about exactly how force feedback works before we move on to the ecosystems and taking a look at the software in more detail. All right, so now that you understand a little bit more about how force feedback works and how the data from the sim ends up in your hands through the wheel, now we can talk a little bit more about the ecosystems that are out there at the moment. So as I'm sure a lot of you will be aware by now, Fanatec have just released their new FanaLabs software in the last couple of days. Now, it is still in beta form, and they are saying that there's going to be a lot more additions to that software made over the next couple of months. So it is very much in its early stages at the moment. But I think it's really important to acknowledge here the fundamental differences between the Fanatec ecosystem and the Simucube ecosystem. Now, I haven't had the opportunity to really have a play with the FanaLabs software yet. I am still waiting for my direct drive wheel to arrive from Fanatec, and I want to wait until that happens before I really get stuck into that in a lot of detail, because I really feel like I want to give it the best chance possible to compete with the Simucube ecosystem. But, you know, I think that it's important to acknowledge that, you know, the two different ecosystems suit different types of people. And it's very similar, in fact, to the whole Apple versus Android debate. Now, the reason I say that is Fanatec is essentially a closed ecosystem. So they control all of the hardware, they control all the software. You know, you can only use Fanatec wheels with Fanatec wheelbases in terms of, you know, all the buttons and things like that. Obviously, there's some third-party adjustments and some third-party peripherals available there, so that you can at least mount it and have the force feedback work. But in terms of, you know, things like tuning menus and stuff like that, you have to use a Fanatec wheel on a Fanatec wheelbase to be able to do that. So the fact that it's a closed ecosystem allows them to do some pretty cool things with their FanaLabs software. Things like allowing the adjustments that take place on the wheel to be replicated in real time in the software, and vice versa as well. So you make an adjustment on the software, you see it show up on the LCD on your screen and things like that. And that kind of stuff is really cool, and it definitely adds to that kind of instant gratification out of the box awesome factor. And I think that's something that Fanatec are really good at, and I definitely want to acknowledge that, because I think that is a big part of the reason why that company has grown so big so quickly. They have been very successful over the last couple of years, and I think, you know, that can largely be attributed to them being very much in tune with what the general customer wants. They want to be able to just sort of have something plug in and have it just work straight away without too much stuffing around. Now, this Simucube ecosystem is a little bit different. It really does let you dive in and fine tune absolutely everything. And I've seen people be quite critical of this in a couple of forums. People are saying, oh, you need to spend hours and hours and hours on every single car to get a Simucube to feel any good. Now, if you watched my first drive video, you would see that that is true to an extent, but also not true to an extent as well. My first impression with the out-of-the-box profile for iRacing was really, really good. Now, I do want to make sure that I acknowledge that, you know, after spending a couple of hours with iRacing and really fine-tuning my settings more, I was able to extract a lot more out of it. But the initial drive was very, very, very good. Now, the impression with Race Room, for example, was very different. Out of the box, it was pretty terrible, to be honest with you. And, you know, that was partly down to the canned effects, like we talked about earlier, but also just the fact that, you know, these software packages are having to cater for so many different types of wheelbases. And something like the Simucube 2 Ultimate, which is on, you know, the very, very, very high end, the very pointy end of the technology, it is always going to take a little bit more fine tuning to get to feel right when you're using it with software that's designed to, I guess, work for the majority rather than the outlier. So, you know, that it is definitely true that there is more fine tuning required to really extract the absolute most out of a Simucube wheelbase. But that is not to say that you can't have a good experience out of the box. And one of the really great things about an open system, very much like Android, is that there is a really great community around this hardware as well. So you can jump on the race department forums, the Granite Devices forums, Simucube forums, and there's a bunch of people there that are very experienced that are willing to sort of share their profiles with you as a starting point. But what I want to try and achieve with this video is giving you a understanding of what all of the settings do so that you can dive in and really fine tune things to your own preference. So, you know, I think it's all well and good to sort of just use somebody else's settings, but where you really stand to, you know, benefit the most from your investment is when you understand how all of this stuff works so that you can really extract the absolute most out of it. So I guess what I'm trying to say here in a nutshell is that while certain ecosystems might suit different types of sim racers better than others, I don't think it's really a case of one being fundamentally better than the other. They're both fundamentally different from each other, and I think that's probably what's important here. So, you know, if you have the opportunity, try out both by all means. Watch my videos where I'm sort of taking you through my settings for the various different sims and my enjoyment, my first drive videos and things like that. I am going to be doing those, of course, for the Fanatec wheelbases as well. But as I said, I really don't want to get into that whole, you know, is Fanatec or is Simucube better? Because I really don't think it's a valid argument to begin with. But anyway, let's jump in now and take a more detailed look at all the settings that we have available to us in the TrueDrive software and exactly what all those settings do. So the first thing that you will notice straight away is that they've really spent a lot of time here making the user interface as clean and tidy as they possibly can. A lot of these type of companies that sort of are engineering focused first and foremost tend to get stuck in the trap of making their software overly clunky and overly complex and convoluted. But this is not the case with the Simucube TrueDrive software. It is very clean. All the stuff that you need there to extract the most is available, but it's not, you know, it's not cluttered. It's very straightforward to use and very, very simple straight out of the box. So let's get the wheel fired up quickly here now. Take it out of standby mode. So straight away, you see it pops up here. It says it's operational. Active profile is my iRacing profile. I'll show you how that all works in a little bit more detail in a moment. We've got our e-stop and motor status. So e-stop is released. There's no errors or anything like that. E-stop obviously being the emergency stop button. So if I push on that emergency stop button, you can see it says e-stop is pressed and that disables all of the torque through the motor. So we'll release that again quickly now. And you can see it comes back again. So you can also see here high torque mode is disabled. Now this is the case by default every single time you fire up your wheelbase. And this might annoy some people, but I actually personally think this is a really good safety feature, particularly for somebody like me that has young kids in the house that do have a tendency to fiddle with daddy's toys when daddy's not around. So we have a button here that says enable high torque mode, and that pops up a little dialog box, which has a bunch of warnings, and you actually have to physically drag this slider across and then click on activate high torque mode to enable high torque. Now there is also a setting that we'll take a look at a little bit later that disables high torque by default automatically when it detects that nobody's touching the wheel, and that's a great safety feature as well. So if you're sort of sitting in the pits or something and you know you forget that you've got your wheelbase on, it'll automatically go into low torque mode until it detects that you've got your hands on it. Kind of like how it works in a Tesla actually. But anyway, we're digressing there a little bit from the point. But yeah, a little bit different from how Fanatec work there. Fanatec uses the torque key, which is like a physical thing that you install in the wheelbase to enable high torque. I'm not sure because I haven't got my wheelbase from them yet whether you still have to enable it every single time, but definitely a good feature there to have that so that it can be disabled if you're not wanting to use it, and that you actually have to enable it every time. Might be a pain for some people, but you know, you get used to it and it's not really a problem. And I think the benefits of the safety outweigh the small pain in the ass that it is to have to re-enable it every single time. So you can see here we've got our Asher Racing wheel displayed as the wheel that is connected. Now that is actually a manual process. I'll quickly show you how that works now. It is a PNG image that you can get supplied to you by your wheelbase or your wheel manufacturer rather. So Martin from Asher Racing sent me this PNG, and all you need to do is just drag it into the root directory of your Simucube driver software. So you can see there wheelimage.png, and it's automatically picked up by the software. So you close the software, reopen it, and your wheel will show up there. So by default, you would have seen it in my first drive video. It actually almost looked like a Logitech G25 that showed up there. But yeah, you can adjust that to be any wheel that you want, which is a nice little touch there. Now by default, and you can see none of my buttons are working because we're not connected yet. So what we need to do is jump down to our wireless connection tab here, and you can see the wheelbase is automatically in pairing mode or scanning mode by default. So we switch on our F28 SC wheel, and immediately it will connect there. We have previously paired it. All we need to do is just click the connect button. You can see that in my first drive video where we paired it. You can see our battery voltage is displayed, shows it as being connected. And then if we go back to the original tab again, you can see now connected Asher Racing F28, battery voltage displayed, and our connection strength as well. And as I showed in my first drive video, you see the connection strength does vary slightly depending on the position of the wheel. And if you have, I think Barry Rowland actually showed it in his review of this wheel. If you have a big steel plate type rig in front, it can actually block the signal a little bit. The signal strength does go down a bit. But for me, I've got a pretty clear signal path from the wheel to the receiver on the back of the wheelbase, so my signal strength doesn't drop too much there. And you can see now when I push the buttons, the various different button presses show up on the screen just here. So see the button presses there. Now, one other thing that we can do from here as well is set our wheel center position. So we click on reset center. And I don't know exactly why this is grayed out, but we've got a thing here that says just set wheel center position here for now. But for some reason that's grayed out. So what I'm having to do is every time I want to reset my center, so if I switch to my other wheel, which is off center for my quick release, I actually have to readjust it. Now, it's not really a problem because you're only clicking one button anyway, but I'm not sure why that is grayed out. I don't know whether I'm doing something wrong or something. I'm sure the guys in the comments will correct me. But yeah, we click on set permanent wheel center, and that will adjust itself after a couple of seconds. Now, this is actually really cool here, so I just want to show you this. You can see here we've got 0.00 as our wheel position. Now, look how sensitive this is. When you consider we've got 900 degrees of rotation here, look how sensitive this is. So I'm brushing against the Alcantara, and that's picking it up. Like, that is just ridiculous, the amount of sensitivity that we have there. So that just goes to show the level of hardware that we're dealing with here. This is not a toy. This is just ridiculous. So yeah, just thought that was something interesting there. You can see as I turn it, it goes all the way up to 450 degrees in each direction for a total of 900, obviously. But yeah, it's just the amount of resolution that is there is just ridiculous. Anyway, let's move on. So that is the overview and connection tab, and you can see it's only the information that we really need there. There's no unnecessary clutter, really clean, really simple to use, and you really don't need to read a manual to know how to do it straight out of the box, which is always good. So let's skip over the profile and hardware settings tabs just for now and go to information. You can see we've got the Simucube 2 model that's connected shown, a revision of the hardware, firmware, and true drive version as well. Now, if there is a firmware update available, that will automatically pop up and prompt you to install. You can also check for updates on the software here. So depending on the latest version of software that you have installed, it will automatically pop up and detect that there's a new version of firmware. And you would have seen that again in my first drive video when we first connected it. It did prompt me to install the updated firmware first. We've got a couple of little resets and warning things here that we don't need to go into too much detail. We can start everything from scratch. We can reload settings by default from Simucube. We can also reset our force feedback state. You can download debug event log, and that's a useful little tool. If you have any problems, you can send that through to the guys at Granite Devices, and they can take a look at it and improve their product from there. And then we can also set the log verbosity level as well. So we can set it to, you know, show how much detail is going to be logged. And yeah, pretty self-explanatory there as well. So let's go on to our profile page here now. And this is where we get into all of our fine tuning and adjustments. So by default, straight out of the box, we have a bunch of profiles that are available to us. And if we click on add, you can see here, we'll bring this across. We've got a default profile for iRacing, Dirt Rally 2, RX, R Factor 2, and Race Room. So these are, I guess, canned profiles out of the boxes that are provided by Simucube, and it's really great that they do give you those as a starting point. And as you'll see in a moment, as we kind of touched on earlier on in the video, you know, you really are rewarded by fine tuning here. So even though I was really impressed with the iRacing profile in particular straight out of the box, definitely was a lot happier once I jumped in and did a bit more fine tuning. But again, I think really the holy grail here in terms of direct drive wheelbases is, you know, having a really detailed suite of profiles, even going into the level of individual cars as well, so that you can just go, all right, here's a starting point profile for this particular car. We suggest you load this, and then you can make some fine-tuning adjustments from there to suit your driving style or your physical strength as well. Because when you're dealing with a wheelbase that has as much strength as this one does, you know, if you're a really, really strong person, you might actually want to have your force feedback turned up a lot stronger than, you know, somebody who's got girl arms like I do. And, you know, this is the case with real-life racing cars as well. People like to set up their cars differently. And, you know, different people like different amounts of weight in the steering, or, you know, all kinds of things. So it really isn't a one size fits all thing in the real world. And, you know, it isn't in the sim world either. But we do have these canned profiles by default. And when you select one of these, you also get a prompt. We'll select R factor, for example. You can see here there's an additional information tab here as well. So for R factor 2 as of July 4th, a Simucube device is not detected automatically with optimum force feedback settings. Setting templates that work better can be downloaded from here. So that link takes you through to the Granite Devices forums, and there's a bunch of settings there that are available for you to load into Raceroom itself. Now, obviously, there is a lot of fine-tuning that you can do inside most sim software as well, and we will talk a little bit about the relationship between the settings that you have inside the sim and the settings that you have inside the driver software as well a little bit later on once we get into the nitty-gritty all of these settings. Now, of course, if you don't want to use one of these out-of-the-box profiles, you can create a new one from scratch as well. And all of those profiles are then available in your management menu here. So you can see I've created one here for F1 2019. I've also created a specific one for the Ferrari 488 GT3 in iRacing as well. And one thing that I think is important to understand here is that, you know, to really get the most out of this, you probably are going to need to set up profiles for the individual cars that you drive. My default iRacing profile here is pretty good as an all-rounder. I can drive an MX-5, I can drive a Skippy, I can drive, you know, any sort of car like that with it just fine. But I find when I jump in the Ferrari, because the handling characteristics of the Ferrari are so fundamentally different to, you know, an MX-5 or a Skip Barber, I did have to make some adjustments there. And I'll quickly show you the differences between my adjustments there. So that's my default iRacing profile there on the settings. And then if we go to the Ferrari one, quite a bit different. Static force reduction is different. Low latency mode is a little bit different. But we're going to go into the detail on all of that in just a moment here. So we'll start off with our iRacing setting. And yeah, let's talk a little bit more about exactly what all of these individual settings mean. Okay, so time to have a look at these individual settings in more detail. Now, I apologize for looking away from the camera a little bit here. I am going to be referencing some notes that I've written down here to make sure that I don't miss anything here. But let's get stuck into this. So, steering range. This is the range of movement which is outputted from the wheelbase into your sim. So the amount of adjustment that you have here, or the amount of range of movement. Now, this is not to be confused with the bump stop adjustment, which is directly below it. You can see at the moment with a range of 900 and a bump stop range of 900, we have 900 degrees of rotation before we hit those bump stops. Now, if we adjust our range to 210, say for example, you can see there the bump stop range also adjusted down to 210. And now when we turn the wheel, as you would expect, we have a bump stop range of 210 degrees before we hit those bump stops. Now, there are some other adjustments here on the settings page, which we'll have a look at in a moment as well, with regards to bump stops. Now, because we don't have a mechanical bump stop actually built into the physical wheelbase, we can adjust this through the software as well. So if I want my bump stop to be different from the steering range that's actually inputted to the sim, what I can do is I can ramp that up. And you can see now I can actually go 260 degrees on the wheel before it stops. If I crank it back down to 210, again, you can see it stops. It's now stopping there. So we do have a range of adjustment there as well. So if for some reason, say for example, you want to hit a bump stop before you actually reach full scale deflection inside the sim, you can do that, which is pretty cool. But let's set that back to 900 now. And we'll go back to that. Should also automatically also bump to 900. Yep, there it goes. Now, while we're still on the subject of bump stop, we do also have some more adjustments under settings here as well. So we've got a bump stop mechanical strength, which is the physical strength of the bump stop. Now, you can see at the moment, when I have that bump stop there, I can still turn past it. I can feel it, but I actually have to exert some force on it to go past that. And then when I hit that, it automatically springs back to the maximum sort of full scale deflection that I've programmed in there. So we can adjust the strength there, so I can make it so that it's almost impossible to move past that point. I can also adjust the angle of how steeply the force is applied to the wheel as it nears the bump stop as well. So that kind of gives us a nice soft feeling. So as we approach it, so we can see there with 10 degrees, we've got a nice sort of area of 10 degrees of movement that sort of feels a little bit springy before we kind of hit that point where it goes, all right, no, you've hit the bump stop. And that's adjustable as well. So that's really cool. I like to have that set to about 10 degrees. Gives it that nice kind of real car feeling. You find in a real car when you hit those bump stops, you know, there's a little bit of give there before it just just stops. It's not like just hitting a hard stop. So that simulates that quite nicely. We also have the bump stop damping effect as well. So dampens hard hits to the bump stop and prevents the bounce back as well. Now there's a couple of other settings here as well that we may as well just quickly skim over while we're in the settings panel. So audible notifications enabled. So you can actually have the motor chime and chirp and give you notifications. So when you turn it on and off, it will beep at you. Also, when it detects that there's hands off or when there's torque clipping as well, you can switch that on and off. And a really cool little fact there is that there isn't actually a PCO electric buzzer or anything like that, a little squeaker inside the wheel. It's actually the signals being sent to the motor itself that creates those tones. And that's just, I guess it's a bit of an engineering marvel for a mechanical nerd like me that kind of likes this stuff, because you know, they're able to send such a high frequency signal to the motor that it actually creates that tone, which is really cool. And we'll actually touch on noise a little bit later on as well, because that's something that another setting influences a bit. But we've also got our centering strength when we're on the desktop as well. So when we're not connected to anything and we're just kind of sitting idle, the amount of centering strength. And you can see at the moment, when I don't have any centering strength through it, it just kind of sits wherever I leave it. If I crank that up, it'll go back to the center. So, I mean, I don't really see any need to have that enabled, because, you know, when you're not driving anyway. So it kind of makes sense to just leave it on 0. And that way, if, you know, if somebody comes up and the kids are playing with it or something, it's less likely to sort of spring back on them and hurt them or something. We've also got a filter here for resonance reduction as well. This is kind of like the FEI setting on Fanatec wheelbases that you might be familiar with. What this can do is reduce the amount of metallic resonance that you get, or those kind of resonant noises that you get from the motor when you've got really, really high frequency signals coming in. So I haven't felt the need to switch that on. I actually haven't had any issues with noise at all in the sim titles that I've been playing with so far. I haven't tested out R factor yet though, so I don't know whether, I think if anything is going to do it, probably R factor will. But yeah, I haven't had the need to switch that on. We also have some settings here for suspend and recovery support for USB as well. Don't really need to go into that. And we also have configuration for our analog inputs. We don't have any analog inputs on this at the moment, so we're not going to touch on those today, but it's good to see that we do have some adjustment there as well, so you can adjust the sensitivity of the inputs and things like that. So back onto our profile tab again and onto overall strength. So historically with overall strength, this has been something that people have used to sort of impact a lot of different things. So I remember, if I cast my mind back to my Logitech G27 days, you'd use the overall strength of the force feedback to kind of, you know, give the overall effect of, you know, how hard the wheel is to turn in corners, you know, how strong the ripple strips feel, how strong the bumps feel and everything like that, because you didn't have granular adjustment available for all those individual things. So what we want to do here is a little bit different. We kind of need to adjust our mindset a little bit. The overall strength of the force feedback is basically what we want the absolute maximum force feedback that we ever want to feel to be. So the reason why I don't have this set to the absolute maximum, and a lot of people do recommend that you do set this to 100%. I don't have it set to the absolute maximum simply because this is a, you know, this is a very strong wheelbase. It goes up to, what is it, 31.4 Newton meters, which is very, very, very strong. And, you know, I actually nearly did break my thumb the other day because I held onto the wheel when I crashed into a wall in the MX-5, and it went immediately to 100% force feedback, and it just jerked my hand. And, you know, 31.5 Newton meters is literally strong enough to break your hand, or even, I think it'd probably even break your arm if you had your arm through a wheel or something. So we only ever want to have, or at least for me, I only want to have my overall strength set to the absolute maximum that I ever want to feel. Now, because we have more granular adjustment, in particular our static force adjustment here, we're actually able to fine tune those other adjustments. So say, for example, you want to be able to feel the effects like ripple strips and bumps and grass and textures and things like that to, you know, a really high strength. But you also, at the same time, you don't want to have the wheel feel like it weighs an absolute ton as you're trying to turn, or you don't want the G-forces to feel, you know, overpoweringly strong. You can actually use the static force reduction adjustment to reduce the amount of strength that you feel in the static forces like cornering without reducing the strength of the effects that you're feeling. So it kind of gives you the best of both worlds there. And I think it's a bit of a game changer there. We'll touch on that a little bit more when we talk about static force reduction. But yeah, my suggestion here is that you crank this up to the maximum amount of torque that you're ever going to want to experience. So in something like a crash scenario, we don't want to be trapped in, or we don't want to be tricked into setting this to the amount of force that we want to feel in cornering, because really what we want to do is set that inside our sim software, or use our static force reduction adjustment to set the amount of force we feel during cornering, and leave our overall strength to sort of stipulate what we feel in something like a crash or hitting a bump or getting hit by another car. And that allows us that sort of granular fine-tuning adjustment there. So hopefully that makes sense to you guys. I generally keep this at around sort of the 15, 16 Newton meter mark, which I feel, at least for me with my girly arms, is pretty good, and, less likely to break bones or give me a serious injury. So time to move on to our filters now. Now, there are two different types of filters that we have available to us in the software here, and it's very important to understand the difference between the two. So we have our constantly operating filters, and we have our direct input effect fine-tuning filters as well. Now, this is where we sort of get into that signal processing stuff that we were talking about with interpolation before at the start of the video. So our constantly operating filters, these are the filters that are actually operating at a firmware level on the wheelbase itself. So those are what influences the signals right before they actually get outputted to the motor. So this is the interpolation that's actually happening, on the signal processor of the wheelbase itself. Whereas our direct drive effect fine-tuning, they are effects that are done at a driver level to filter the outputs from the sim software. So you've got basically, it's kind of like an amplifier, for an audio system. You've got your preamp, which is what actually, does the fine tuning and EQs and stuff to the audio signal before it reaches the final amplifier, which is what amplifies it to the speakers. So you can kind of think of your constantly operating filters as the amplifier that's driving the speakers or the motor, and then the direct input effect fine tuning, kind of like a preamp, which is what's doing your EQ and stuff like that before it actually reaches the amplifier. Now, this is where it starts to get really complicated, because obviously you have your adjustments inside your sim software itself as well. And there's a little bit of argument here online, and I'm going to try to explain this the best way I can. The adjustments inside the sim itself are what are actually influencing the signals that are coming out of the sim. So those direct drive data signals that are coming out are what are influenced by the sim itself. Now, you might think, therefore, that it's better to make all of your fine-tuning adjustments there, because that's where, it's the most raw. It's kind of like a preamp on top of a preamp, so to speak. But the trade-off there is that the processing that actually takes place inside the sim is often a lot slower than it is inside the driver that we have here with TrueDrive. So basically, you want to keep things as simple as you can inside the sim itself, sort of just making sure that your scaling is correct. So things like, your turning force and your bump force and things like that aren't, overpoweringly strong compared to other things, so that the signal that's coming out of the sim is as clean as possible. So you want to sort of have it as linear and, as wideband as you can, I guess, coming out of the sim. And then you want to do a bit more fine-tuning adjustment in your direct input fine-tuning. So this is what sort of applies filters to the software, to the signal that's coming out of the software. Now, what I like to try and do here is keep this as simple as possible. And you can see here, my spring, my square wave, my sawtooth, and my triangle adjustments are all pretty clean. And generally speaking, if the sim software is pretty good, you're not going to need to do a whole lot of adjustment here. You can adjust your friction and your damping a little bit, and we'll talk about what all of these settings mean in a little bit more detail in a moment. But generally speaking, you're not going to need to do a whole lot of adjustment here unless there's something that you're specifically compensating for, like an area of weakness in the software that you're using. So unless you're trying to compensate for an area of weakness, sounds a bit rude. Yeah, definitely trying to compensate for an area of weakness. But yeah, unless you're trying to do that, there's really not a whole lot of need to adjust here. And I found with iRacing in particular, didn't need to adjust much at all. Remembering again that iRacing does use physics-based effects. It's not using canned effects, so it's a little bit stronger there to begin with. But again, remembering that we do have that sample rate of 60 Hertz. So we do need to do a little bit of filtering there just to keep things feeling as good as they can possibly feel. So let's have a little bit more of a talk about the direct input effect filters first, and then we'll move across to the constantly operating filters that are operating at a hardware level. So let's start off with damper. This is effectively the amount of resisting force that is fighting against the wheel rotation. So not only the wheel rotation as you input, so it's not only fighting against you, it's also fighting against the inputs from the game itself. So if your game is telling the wheel to go like that, the damper is kind of what counteracts that. Now, this is often where you can see that kind of oscillating thing going on. So you might be driving down a straight, you let go of the wheel and you see the wheel starts to go like this. That's because you have what's called overshoot. And what's happening is you've got the sim is telling the wheel to do something, and then you've got your damper, which is sort of counteracting that, telling it to do the opposite. And there's a little bit of overshoot there. So what it kind of does is it's almost like an echo chamber. It's like feedback. It kind of just goes back and forth, and gets stronger and stronger and stronger until the wheel's going absolutely mental. So the damper fine-tuning adjustment kind of counteracts that a little bit. Now, the friction effect is pretty much the same thing as the wheel weight effect inside your sim software as well. So this sort of determines the overall weight, or the friction of the tires, the friction influence from the steering whack and the bushings and all those kinds of bits and pieces. So again, if your sim software has a wheel weight adjustment already in it, generally speaking, you can just use that. And again, if you just need to make any little fine-tuning adjustments from there, you can do so using here. But generally speaking, I like to keep this pretty low, and then I end up doing my fine-tuning adjustment using the constantly operating filter at the end. And again, I'll explain that a little bit later on. Now, our spring effect is our returning spring. So this is the force that's trying to fight against you to return the wheel to the center at all times. So this is often also adjusted inside the game itself. Some titles don't have a wheel centering adjustment, but most of them do. So in the case where you do have a wheel centering adjustment, generally speaking, you just leave this at 100 and make the adjustment inside the game itself. Again, only if you're finding that you're getting kind of a notchy feel, or the game that you're playing doesn't have a wheel centering adjustment, you generally don't need to touch this at all. So sine wave, square wave, sawtooth, and triangle. These are all adjustments that counteract that robotic feeling that I was talking about earlier with the output from the direct drive API. So what's basically happening is, instead of having a beautiful, clean, curved sine wave, what's happening is, because the sample rate is relatively low, you're getting a bit of a square wave kind of effect. So these are all fine-tuning adjustments that kind of counteract that. So if you're finding that you're getting kind of robotic feeling out of the game, you can adjust these various different things. And I'm not going to go into a whole lot of detail on each individual one here, but basically sine wave is used, as it says in my notes here, in some games to make sinusoidal vibrations of the torque. So if you're finding that those sort of movements are a little bit robotic, you can use that to adjust that. Square wave effect is used to sort of soften off the sharp movement. So if you're getting rapid movements like that, and you're finding it's kind of like the wheel's here, now it's here, now it's here, then that can kind of smooth that off a little bit. So it kind of turns it more into more like a sine wave. So sawtooth is more like a filter for things like ripple strips and stuff like that. So if you're finding that the ripple strips feel robotic and really, really grainy, you can smooth those off a little bit and make them feel a little bit more realistic, again, depending on the output of your sim, by adjusting that adjustment there. And then the triangle adjustment is for fine-tuning torque signals that rise and fall at a constant rate. Now, before we move on, I'm going to take off my hat because it is getting crazy hot in this room. So on to our constantly operating filters. Now, just to reiterate once more for you, these are the filters that are running on the signal processor on the wheelbase itself at a firmware, almost hardware level. So these are kind of like the last line of defense. These are the very last things that influence the signal before it actually gets outputted through the motor and into your hand. So this is where the final fine-tuning adjustments to anything that's still feeling a little bit robotic all take place. So starting off with our Simucube force reconstruction filter. This is a interpolation filter, basically. We talked about interpolation before, inserting those extra bits of data between the real data to smooth off the edges. So interpolates between telemetry input and reduces or completely eliminates the robotic feeling inherently generated by sim data. So kind of like smoothing out a staircase. I think that's a really good way of looking at it. If you look at the stairs of a staircase being bump, 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 with each bump being a packet of data, what we're effectively trying to do here is smooth the whole thing out so it becomes like a slide. And that's what gets rid of that horrible robotic feeling. So generally speaking here, Simucube, or the guys at Granite Devices, recommend a setting of 5, which is about in the middle here. We'll just quickly read out to you as well exactly what they say about this directly from their own little wiki. So this filter allows the motor controller to take a slower digitized incoming signal from a program at any frequency and reconstruct it based on a complex algorithm to increase the accuracy and smoothness of the signal while fully retaining the integrity of the original signal. So that is pretty much a technical explanation of interpolation for you right there. This allows the Simucube to update positioning and force information on the servo, which is the motor, at the motor's controller with maximum possible rate, which smooths the action of the wheel while retaining all detail in the signal with minimal drawbacks. So what it's basically saying there is that it's filtering the signal, but it's not weakening it. It's not making it feel. It's not reducing the overall fidelity. So I think it's kind of, again, you can kind of use audio as an example here. It's not like we're taking a shitty quality MP3 and then putting a bunch of filters on it to try and make it feel good, or we're not taking, you know, a really high quality FLAC file or something like that, and then putting a bunch of filters on it to make it sound different. Where, you know, we're not losing any of the integrity or the fidelity in the original data. We're just manipulating it slightly to suit our personal preference here. So I guess that's probably the best way to explain that in more layman's terms. Setting this filter off disables it, and the standard signal from the program being used is passed to the firmware. Yep, we understand that now because we talked about how the direct input kind of influences and gets filtered. Currently, the numbered options for the filter indicate the aggressiveness of the filter. At higher numbers, the filter is more aggressive and will take longer to reconstruct the signal, which will induce more latency or delay into the signal. Currently, the effects of the numbers are not linear and can result in many differing effects when they vary between smooth and abrupt or even unstable. So you might find you need to kind of vary this a little bit depending, but I haven't found a scenario yet where 5 didn't work quite well for me. And when we have a look at my various different profiles a bit later on, you'll see that as well. So that is the Simucube Force Reconstruction filter. And I think that's probably the one that has the biggest influence overall over the general robotic kind of feeling that you might have. So on to torque bandwidth limit. And again, I'm going to read out Simucube's own explanation of this. So this setting is a filter point for the incoming set point information received by the motor controller. So there you go. That's basically what that's trying to say, is it's a filter for the data that's telling the motor what position it needs to be in its rotation effectively. The lower the setting, the more smoothing due to cutting the higher frequency information from the signal, and in turn will slightly increase the latency, which results in a more dull and subdued feeling at the wheel. Generally, you want to set this to as high as possible to allow for the most unfiltered information to get to the servo drive. That makes sense. Obviously, you want to have as much data coming through as possible. You don't want to be, you know, trimming it off too much. When using the reconstruction filter, it's best to set this as high as possible, usually unlimited. Some game titles do require lower TBW settings due to aggressive, noisy, or sharp feedback signals being implemented in their force feedback signals. I think this is probably pretty similar to the FEI setting, and we kind of talked about this before. Similar to the FEI setting that you have on Fanatec's wheelbases. Effectively, what it's doing is it's allowing you to reduce the frequency of some of those signals to get rid of some of that sort of high-pitched stuff. Or, you know, sometimes you might get sort of really, really fine data that's coming through that's just adding detail that you just really don't need to feel, or might be, you know, even adding robotic levels of detail. So this is a way to kind of filter that off. So you want to leave that set to the highest level that you can, unless you're feeling problems. And again, the default profile out of the box for iRacing here had 2200 Hertz. I did experiment having it a little bit higher, and I didn't really feel a whole lot of difference in the feeling. So I just set it back to 2200 again, and that seemed to be fine. But yeah, that is the torque bandwidth limit. So now on to our other filters. Now you can see we do have some double ups here. We've got dampening and or damping and friction, which are also in the direct input effect as well. So remember from earlier, the direct input filters are filtering the data that's actually coming out of the sim before it's processed by the signal processor on the wheelbase, whereas these are fine adjustments that take place after the effect. Now, the reason why you might want to make adjustments here rather than down here is because the sample rate or the update rate of the processor on the wheelbase is a lot faster. So all the fine tuning in the world here doesn't necessarily, or it can't match the fine tuning or the, I guess, the sample rate or the update rate that's happening on the wheelbase itself. So even all the adjusting in the world here can still feel a little bit robotic on a direct drive wheelbase like this, unless you have additional filtering down here as well at the final hardware level before it gets through the motor. Hopefully that makes sense. So dampening and friction effects are basically defined exactly the same way. So we'll read out the definitions from Simucube again just for you quickly. So damping. Damping within the motor controller is designed to limit the overshoot that the servo itself is inducing due to the velocity of the armature. So the filter works by trying to resist all the movement by creating a signal that tries to reposition the servo back to its intended location. Increasing the percentage adds dampening. Think of it as setting a shock absorber for the wheel, and it does not change the feedback but will slow the resulting effect as it reaches or returns to its destination. The goal of this setting is to cut the unwanted positional errors due to the servo overshooting and the intended positioning, which could result in unintended forces being delivered to the servo due to the positioning of the servo being out of position when the force is sent to the wheel. That was very, very wordy, but basically what it's talking about is that oscillation that we were talking about before. This overshoot error can show up as, there we go, this overshoot error can show up as oscillations of the wheel when dampening is set to low, since the wheel will overshoot and the game will try to correct the issue, causing the wheel to overshoot in the opposite direction, causing a feedback loop. This is exactly what we were talking about before. In the case of the Simucube, if you turn the dampening up too far and over dampen the system, the steering will feel dull, and as it will continually try to adjust a return to the intended position, resisting both your actions as well as the feedback signal. It's normal to have a small bit of over dampening in the system to be able to reduce the possibility of oscillation. This setting is best used to dull the feel of the wheel, as it reduces the reactiveness of everything and sort of flattens the feedback feel. This can make the wheel feel at times sluggish. But at the same time, due to the nature of dampening, trying to stay on the position, it can also ease the steering effort and load, because the wheel will be actively trying to stay in its intended position. In terms of car feel, more dampening feels a bit more soft or underinflated on the tires, while less dampening feels like tires that have been overinflated or have harder sidewalls. So yeah, pretty much exactly what we explained before under the direct input. This is just a fine-tuning adjustment for the final dampening before the signals come out to the wheelbase. So friction, we already explained this before. This is basically the force that's required to turn the wheel by the driver, and it's basically mimicking the drive, or not the drivetrain, the steering train forces. So, you know, your steering rack, your tire friction, you know, contact patch on the road, your rack and pinion, your bushings, all those kinds of things. So this is fundamentally different to damper, and this is where a lot of people with cheaper wheelbases, they often use the damper adjustment to try and make the wheel feel like it has a bit more friction. Now, the difference between, and this is really important, the difference between friction and damper is that damper actually scales the amount of force that is fighting back up against the movement of the wheel, you know, to counteract it in real time. So it's actually a scaling amount of force that's being applied, whereas friction is a constant force. So basically it's saying, I want the wheel to be this heavy regardless of what else is going on, and it just stays there all the time. So Simucube's definition here, this filter will also limit the amount of rubber band feeling. This effect comes from the fact that the force feedback for the most part is designed to return the steering wheel to the next position or point no matter what you do. And to do that, it adds power in the opposite direction from what you're turning. The rubber band feeling comes from when you too quickly turn in the direction that the force is wanting you to go, and then the wheel is moving faster than you can turn it yourself. You effectively lose all the feeling in the force and the turning of the corner, and you'll feel that this as the steering wheel suddenly gets heavy at the other side. So what they suggest here in terms of adjustment, by adding friction percentage, you'll be slowing the rate of the wheel's ability to return to the center in a more progressive manner by allowing you to turn the wheel back towards the center and retain some of the feeling of the force in the return motion. Wordy again. Note that the higher you set the friction, the more friction you'll have in both directions of movement. So by adding friction, you can increase the force required to turn the car to a possibly unacceptable level, as this will diminish the speed of the wheel return. So yeah, if you add too much friction, you know, it's kind of like having a damper on your throttle pedal. You lose the ability to accelerate quickly or to have quick lift off, because, you know, it's a slow progression. So very similar. So this setting would be best used if you feel the forces of the wheel are correct, but the steering feels overly light in the nature or during certain movements. So by increasing it, you're not seriously affecting the way the feedback translates the wheel to the wheel, but you're adding weight to the steering, mimicking the drag that would be in a real life steering rack. So hopefully that makes sense. It's not overriding or overpowering any of the other effects. It's just adding weight to the steering wheel on top of that. So definitely not to be confused with the damper. So on to inertia now. Now this is a lot more simple to understand. Basically, inertia is the weight of the wheel continuing to turn the wheel once you let go. And this is actually probably the thing that impressed me the most about this wheelbase. If I crank up that inertia value now, you can see when I turn the wheel, it wants to keep moving afterwards, and it genuinely feels like turning a big stone wheel, or trying to, you know, you got a big heavy truck wheel that you're trying to spin on an axle or something. It really genuinely feels very, very, very realistic, and there's no notchiness there whatsoever, which is pretty remarkable when you think about what's going on in the background. It's actually going, all right, I'm in this position, now I want to move to this position with this amount of force and this amount of force and this amount of force. It blows my mind to think about how much detail is going on there. But if we crank that down to 0, you can see immediately it just kind of stops, and it almost feels like it's fighting against you when it's turned off. So I like to have a little bit of inertia there. This is very much a personal preference thing. I usually have it set around sort of 15 to 20%. And I find that feels most similar to a real car, I find, at least the cars that I'm driving at the moment. I have been lucky enough to drive a couple of Ferraris and things like that over the years, so I have a pretty good understanding of how something like a 488 actually feels on the real road. And yeah, it's around sort of this 16 to 20% mark feels about right to me. But again, very much personal preference. So on to static force reduction now. And you'll remember we talked about this a little bit earlier in relation to our overall feedback strength. So I was saying you want to generally set your overall strength to be the maximum amount of torque that you ever want to make it feel or ever want to make it transmit under any circumstances. And then what you can use is your static force reduction to adjust the amount of force that you feel through turns and stuff like that. So historically with, you know, high torque wheelbases, if you want to be able to really feel the bumps and really feel, you know, the curbs and impacts and hitting a wall and stuff like that, then the trade-off to that would be that, you know, when you're going through corners and stuff like that, the wheel can be way too heavy and it can really be hard to turn the car. So static force reduction is basically the answer to that problem. And it works really, really, really well. Really impressed by this one. So what it's doing is it's saying, okay, you've got a sustained force through a corner or something like that. We're going to reduce the amount of torque that is being fed through the wheel. So therefore, what it's doing is it's basically effectively making the wheel feel lighter, but it's not reducing that maximum amount of overall torque that you get through bumps and stuff. So you can be going through a corner, and Nürburgring is a really good example of this, some of those sort of berm-like turns where you really got a lot of force fighting against you through the wheel. But because you haven't had to turn down your overall strength, you're still getting the textures in the road, you're still feeling the bumps. If you happen to just kiss a little ripple strip or something like that, you feel the vibrations through the wheel, and it's really, really, really great. So I've kind of ended up finding around about 40% feels good for me. Again, it does depend on the car that you're driving, because obviously the amount of, you know, detail and things like that are being transmitted through the through the steering and through the tires and everything varies depending on the car and the sim. But yeah, around about 40% for me feels pretty good for most titles. But again, yeah, this is very much sort of a personal preference thing, but that is the point of static force reduction. And yeah, this is definitely a game changer in direct drive wheelbases, because it allows you to, you know, it allows you to sort of have your cake and eat it too. You can adjust your overall strength to be really strong for all the bumps and, you know, impacts and vibrations and things like that without having to make the wheel, you know, so ridiculously heavy that you can't even steer. So down to slew rate limit. So slew rate is the ability of an amplifier to respond quickly to a change in signal. So how that relates to the context of what we're doing here is what you can see here on the screen. We've got a range or a scale of Newton meters over milliseconds. So what this effectively means is that you're limiting the speed at which the torque is able to change. So if you're finding that you've got sudden jerky movements that are way too strong and just feel unrealistic, because remember, you know, in a real car, you very, very rarely are going to have, you know, a sudden, you know, the wheels aren't going to go from that to that without the movement in between. So what this can do is it can take out some of that notchiness that you can feel through the steering sometimes. Now I found that the other filters did a pretty good job of this, and with iRacing in particular, which is what I'm driving most of all at the moment, this really wasn't a problem, again because of that kind of physics-based force feedback as opposed to canned effects. But in in Race Room, I did find that this made a bit of a difference. So I ended up cranking it down somewhere around the sort of middle, and I found that did sort of get rid of a bit of that notchy feeling that I was finding in Race Room. So that is the slew rate adjustment. So the last couple of ones now, ultra low latency mode. I'm not 100% clear on exactly what this does, but it feels like it takes a little bit of the detail out. So it's kind of like it's going, all right, I'm going to ignore every third packet of data or something like that, you know, kind of, you know, taking a little bit of the fidelity out to reduce a little bit of the robotic feel once again. But I found, generally speaking, I actually don't know why that's set to 20 at the moment. Generally, I had it off. And I didn't really feel like cranking it up really made a whole lot of difference. I felt like, you know, with everything else set pretty well and right, this didn't really make a whole lot of difference to the amount of feeling. But again, I'm not 100% clear on exactly what that's meant to do, so I'm not going to comment on it too much. And then finally onto our peaking and notch filter. So this is kind of along the same lines as our slew rate adjustment that we were talking about just before. What this does is it allows you to sort of remove some of that notchiness. So we've got a couple of different adjustments here. We've got a center frequency, and this is pretty much exactly like a parametric equalizer on an audio system once again. So we've got a center frequency here, which is sort of the frequency that the adjustment is based around. So if you've got a particular sort of notch that you're feeling in your force feedback, you can adjust the frequency around that to kind of fine tune that out. So our center frequency adjustment adjusts the frequency that the filter is actually operating at. So we would want to set this to sort of counteract whatever it is that we're trying to actually filter out. And this will vary again, obviously, depending on the sim that you're playing. The attenuation decibels is the amount that the filter is actually going to act upon the signal. So the amount that it's actually going to attenuate the signal. And then our Q factor is the width. So if you can imagine the, if we're taking a center frequency of 3 Hertz, if we've got a Q factor of 0.1, we're only looking at a very, very small frequency range either side. So by increasing the Q factor, we're widening the frequency range that that filter is actually acting upon. So around the 3 Hertz range. So if we set it at 3 Hertz, we increase our Q factor, we've got a wider frequency range that notch filter is going to be filtering in. So hopefully that all makes sense. And that is pretty much, I think, everything. We've got a couple of other little options down here for Simucube 2 Ultimate specifically and early access filters. To be honest with you guys, I haven't really played around with this a whole lot yet. Static force reduction speed, that's like a filter on top of the filter. And again, I really haven't felt the need to play with that. I turned it all the way up and turned it all the way down and honestly didn't feel a whole lot of difference. So yeah, I think this is really, we're getting into the stuff here now where it's like, they're kind of just putting it there for the sake of it so that people that really, really, really get into it can adjust it. But yeah, for 99.9% of people, I really don't think that you're going to ever need to touch these ones. Gamma settings adjusts the torque linearity. So again, how linear the torque delivery is. Center dampening, that allows you to adjust the dampening around the center of the wheel. So you can actually have it feel a little bit different in the middle as opposed to when you get towards the outer ranges of movement. And that can also reduce the notchy feeling that you get. Particularly, remember we had that notchiness in Race Room in my first drive. That adjustment there would potentially help there. But again, I haven't really played with it yet. And then our center dampening angle span, that obviously adjusts the effective area of additional dampening as well. And that is pretty much everything. So look, considering the amount of adjustment that we have in here and the amount of things that we can do, it's pretty remarkable how clean they've managed to keep this software. The only criticism I have of this software at all, honestly, is the fact that if you're like me and you like to use the mouse wheel to scroll up and down, if you happen to be hovering over one of these and you turn the wheel, it does move the slider. And this is a Windows thing rather than a software thing, so I can't be too critical of them here. But I have found a couple of times here when I've been trying to scroll up and down, I've accidentally adjusted something and then I haven't been able to remember what I had it set at. And because there's no undo, you kind of, sometimes you get a little bit stuck. You're like, oh crap, what did I just do? It'd be really cool if they had an undo last thing button down here. So one little thing that I would like to see them add is an undo last change button. I think that would get you out of a little bit of trouble sometimes potentially. But I mean, you can obviously, of course, export your profiles and then re-import it. So once I'm happy with the profile, I would save it. And then if I make any adjustments, I don't like them, I can always just import my previous profile back again. And yeah, guys, that is pretty much it. Obviously, you can copy your profiles as well. So if you've got something like, for example, when I created the Ferrari profile, I copied my iRacing profile and then just made some fine-tuning adjustments from there. But just to quickly run you through, I haven't fine-tuned my race room down to the point where I'm happy with it yet, so I'm not going to show you that. F1 2019, those are my settings there. So I added a little bit of damping, a little bit of friction, but the main thing that I adjusted there was inertia. I just found the data coming out of the game was a little bit notchy and a little bit lacking. And yeah, adding that little bit of inertia feeling, which, you know, obviously inertia isn't really something that most sim titles actually include in their data because, you know, it's very difficult to create that effect based off those 4 parameters that we looked at earlier from the direct input output. So yeah, that was something that I have to add a little bit in F1 2018. Or F1 2019 rather. Assetto Corsa I haven't really played with much yet. Same deal with Dirt Rally 2 as well. And once I do have an opportunity to play with those a bit more, I will do some videos with my settings there. iRacing, you've just been looking at my settings there. And the difference that I did with Ferrari there was basically I turned off my static force reduction and adjusted my ultra low latency a little bit. And that was pretty much it. So look guys, all in all, I've got to say I'm really, really impressed with this software. I think they've really nailed it in terms of, you know, just how much you can fine tune and adjust. And I really hope that this video has been insightful for you guys and taught you a little bit more about exactly how much is going on behind the scenes. I think it's pretty remarkable when you think about it. And I think we really do need to take the time to appreciate just how much stuff is going on in the background. And I think, as I said at the start of the video, the holy grail here will be, You know, when we're at a point where we have a really wide suite, a really massive suite of, you know, profiles for all of these different cars that we can just load. I think, you know, while there is still going to be some fine-tuning adjustment between different people's personal preference, I think if we can build up a library of, you know, profiles for different cars in iRacing and Race Room and all that sort of thing, I think we'll be in a much better place, and we'll sort of be in that best of worlds kind of place where people that are just wanting an out-of-the-box experience can just load one of those profiles straight out, and they'll get a good, you know, experience straight out of the box. And then, you know, people that want to do the fine tuning and really understand all this stuff in finer detail can do so from there. But yeah, guys, I hope that you found this video interesting, entertaining, and insightful. If you have, please make sure you do hit that like button. And I also just want to give a quick shout out to Troy from HRS as well, who's been a massive help with this video. I spent a lot of time on the phone with him, sort of sanity checking and make sure that what I was saying wasn't grossly inaccurate or anything like that. I should just quickly mention, though, that this is all my own research and, you know, just information that I've gathered from talking to people and reading online and stuff like that. So I may have made a couple of mistakes there, and apologies if I have. But yeah, I think for the most part, most of it should be pretty accurate, and I'm sure that's the guys at Simucube will chime in if there's any problems, and I can, of course, come back and do another video correcting and addressing any of those issues. But thank you guys very much for watching. If you do want to pick up any of the gear that you've seen in this video, the links are in the description below. And of course, I will be taking a more detailed look at the Fanatec FanaLabs software as soon as my direct drive wheelbase from Fanatec arrives as well. So stay tuned for that one. But yeah, guys, thank you very much for watching, and I will see you again soon. Bye.